Hello and welcome to this introduction to C#. And we're going to be talking about variables, data types, and operators and conversions in this tutorial. And this is just to get your feet wet a little bit more with C# and visualstudio.net. Now, what I'm expecting in this video is that you've already gone through maybe like a Hello World sort of tutorial and you've read some information on C#. You already have Visual Studio installed and you're ready to go. Now, what is Visual Studio? Visual Studio is an IDE, as we can see here, and that houses C#, which is a language like C++ or Python or VB.NET. Now, C# is part of the .NET family or the .NET framework. And the framework is built for developing applications, and those applications use things like C#, F#, VB.NET. And the main two things that make up .NET is the class library, which is for building the applications, and the CLR, which is also called the Common Language Runtime. Now, the Common Language Runtime is what actually is taking your C# code and is converting it to what's called IL code. That IL code will then take the code that you created and convert that to machine language. This process of converting from IL code or C# to IL code to machine language is actually called just-in-time compilation, or JIT. To put it simply, it's converting the code to native code or machine language. So by using this architecture, .NET is able to allow you to use C#, F#, VB.NET, and they all go through the CLR. They all go through the Common Language Runtime, and they all get compiled to machine language pretty much the same way in the same speed. So you don't have to worry about which language is faster than another language when you're talking about applications or things being compiled through the CLR or through the Common Language Runtime environment. So at this point, we're ready to move from some simple theory to let's go ahead and open up Visual Studio and see how some of this stuff is going to work out for us. So here we are in Visual Studio, and I'm not going to go over some of the simplest concepts like, opening up Visual Studio, getting it installed, because I'm assuming you went through that through the Hello World tutorial that I'm expecting that you've gone through already. So this is not really a Hello World tutorial. We're going to get up and running. We're going to talk about variables, talk about constants, and start really understanding how we can utilize C# in visualstudio.net. So let's go ahead and get started with this. I'm going to go up here to File, and I'm going to go to New. And after I hit New, I'm going to go to Project. When I do that, it's going to open up this template window. I'm going to make sure I'm in Visual C#, and then I'm going to click on the Windows desktop. Once I do that, I'm going to click on the console window application. Later on, we'll be dealing with WPF, but for right now, we're dealing with console window application because it's straightforward, not a lot of stuff in the way. We want to keep things simple, so this is why we're doing that. Down here, you want to go ahead and name your application. And whatever name you put here, I'm going to make sure there's no spaces there. Whatever name you put here is going to name the solution the same name, which is fine. Make sure you know exactly the location in which you're saving it. When you're okay with all this information, everything else can remain the same, and you hit OK. Right now, I already have an application named that same name, and it's giving me this warning. So I'm just going to go ahead and rename this and hit OK. All right, so when you get it up and running, you're going to get this template that's already ready to go. You have this function here, this procedure, that actually is the entry point to your application. So whenever the application runs, this is the first thing that's going to run. This is housed inside of a class. And this is the anatomy of a C# application. So basically, with every C# application, functions are what will be running your application. Functions then exist within a class. So basically, we have classes that holds functions. And in our application, currently, we have one procedure, one function, and that's the main function. This is the function that's going to run immediately when the application runs. So whatever I wanted to do, I can put it in here. So let's dive right into how we can go ahead and start creating some variables. So let me make a variable called name and store something in there. So the first thing I need to understand is the variable type. A variable type is like a box, and you put a label on that box. You put what you want to be inside the box. For instance, if you had a box and there was cereal in there, so you would label it cereal first, right? Let's say if you also had maybe some sort of canister and there was water in there, you would label that canister water. With coding, it's the same thing. I want to call out what will be inside of my box or my label first. That's the data type. So I want to create a string, and a string is basically just words. Maybe it's some dialogue, maybe it's some text, maybe it's some description of something. It's just words. And so without getting into the technical end of it. So the first thing I need to do is say what I'm going to put in this container. So I'll say string. Now my container, I can give it any name. I can call it Bob if I wanted to. But I want to call it something that actually reminds me of what is going to be stored in that container. So I'll just call it name. Now I have myself a variable. I close that variable off with a semicolon. And in C# everything is closed off with a semicolon. Just like English or some other languages, they have an endpoint in which a sentence is closed off. So you can really think of it this way. Whenever you finish a sentence in C#, it's a semicolon as opposed to a period. So right now I have this variable here, but I didn't really store anything in that variable. In order to store something in a variable, I have to do something like this, equals, and because this is a string, and all strings are open, start with a quotation and close with a quotation, and whatever's inside of that quotation is what will go inside of this variable name right here. Right now, an empty string is going in there. There's nothing in there. It's still an empty string, and it's still going in there. So I can go ahead and between these two quotes, I can go ahead and put the name. Okay, so now I have this name, and what's being stored in there is Bob, and this data type of this variable is of a string. So what other data types are there? Well, we got a few other data types, but let's first look at how we can compile this and how this all works out. I first have to declare name in order to use it later. So now let's get this printed out to the console window. So I'm going to say something like console window, console.writeLine, and I'm going to put name in there. So because I've already declared name, I can use name here. So if I were to run this, let's see what happens. I'm going to hit play. And it runs, and you saw the window pop up and then close immediately. Well, that's because in the console window application, you actually have to tell it to not debug so it doesn't close that quickly. There's other ways we can do it, which we'll get into later, by creating our own menu, that sort of thing, or having someone read in some information. There's a lot of other ways we can prevent it from opening and closing with the console window. But for right now, the easiest way for us to do it and actually learn at the same time is to understand that we need to go here to debug, and when we run it, we have to go start without debugging. When I do that, now you see it's printed out Bob to the console window, and then it says press any key to continue. When I do that, then the console window closes. There's another way to do this is by on the keyboard hitting Control F5. It does exactly the same thing. So what I'm going to do is I'm going to pause the video for a second, and I'm going to type these data types out, and I'm going to come right back. So I have these data types here. As you can see here, I have string here. I have another string that was just like the string I did before. Then I have this Boolean, and Boolean is basically an on-off. Let's say like a false or true or false variable that you can put in there, and the data type is called Boolean. We have another data type called byte. We have another data type called int, float, double, and char. Now, these data types, basically what they mean is how much information can you put into that box, into that variable. So right now I have this box. I'm using box as a metaphor, but basically this variable is a string. This variable here is a Boolean, and they all hold a certain amount of information. So when you look at this primitive types chart here, you can see here where byte is holding, it has one, this is how many bytes that it has. It has 1 byte here. This one has, the short has 2 bytes. When you get all the way down here to integer, and you get all the way down here to double and float, you can see here a double has 8, a float has 4. So doubles take up more. They use more space than a float does. So what we're saying is, if I declare something a byte, and the range or the size that it can take is between 0 to 255, if I were to go 256, then it shouldn't be able to be stored inside of a byte because that would be too big for a byte, right? Well, let's see. If I go over here, I have, where's the byte? Okay, so I have this number as a byte. And basically, the highest number is 256. So I'm going to go 256 there. And I should get it, yeah, and there it is. I get an error there. So I'm going to try to run this and see what happens. And as you can see, that red tells you there's no way this application is going to run because there is a syntax error. Syntax meaning what was typed in here, the code is not correct. And so I'm going to go ahead and click on no, and then I'm going to go down here to my error list, and I can see right here in my error list it says constant value 256 cannot be converted to a byte. Why? Because we already know, based off of our chart, that it's way too big. But I can do 255 there, and I won't have a problem. So we see what these data types are for. These data types tell us how big can this variable get. So right here, let me pause for a second and give you just a quick overview of what a byte is, how big it is, or a comparison between a bit and a byte. So what's a bit? A bit would be, let's say if I had these 4, let me make this out of a comment. Let's say if I had these 8, 1, 2, 3, 4, 5, 6, 7, 8. Each one of these zeros would be a bit. So that is a bit, okay? 8 of these would be a byte. So when I'm talking about, let me see here, when I'm saying that this byte right here is between 0 and 255, you kind of get a little bit more understanding of what I mean by that. So let's put this in perspective. Okay, so I have an integer here, and it says it has 4 bytes, whereas a byte is 1 byte. Obviously, we just talked about that. A short is 2 bytes, and an integer is 4 bytes. So let's see how that would look. So if this is a byte, that equals a byte. Then what's an integer? Well, it says an integer is 4 bytes. So I should be able to go 1, 2, 3, 3, and 4. So if I were to do something like this, if I were to say byte num equals 1, and then I were to say int num equals 1. While both of these actually do equal 1, one of these are actually going to have to be converted to another because we're dealing with 2 different data types. So with a byte, when I say equals 1, basically I'm doing this. So that 1 goes something like this. When I do something like this for an integer type, basically I'm going to do a 1 here, and what's going to happen is the system is going to fill the rest up with zeros. So if I were to take a number and put it inside of an integer, we can see a number like a byte. We'll say take this num and put it inside this integer number a. We don't have a problem because we have enough space. But if I were to take this integer and try to convert it into a byte, there isn't enough space. So this should give you a visual and understanding of the difference between the data types and why they are important. The majority of the times in C#, you're not going to be seeing people use byte because it's perfectly fine to use integer just in case you might have a larger number or whatever. You won't have a problem with it. So let me quickly give you an example of this. I'm going to go ahead and print out both of these numbers here. All right, as you can see, when I print that out, I get 1 in both of these, which is no problem. That's not a problem. But let's say if I wanted to convert one number into another number. So what I can do is, whenever I want to convert a number into something else, I can use the conversion capabilities of C#, and it's called casting, when you want to cast a number as something else. So I really want to cast this int into a byte. What I do is something like this. And that's saying I want to take this number and cast it into a byte. And I just need to go ahead and close this up like that. So I'm going to go ahead and run that. So I don't really have a problem with this because this number right here fits into a byte, no problem. But remember what I said before, that a byte goes up to 255. So let's test this out even further. I'm going to go ahead and take my number, this number here, and I'm going to make it out of 301. And I'm going to go ahead and try to run this. Right now, you notice I'm not getting an error here. So I'm going to go ahead and try to run that. And look at what happened here. It gave me 45. Because what it tried to do is convert this 301 to a byte. So it just deleted, it got rid of a lot of information just to get it stuck in there without giving it an error or anything like that. It just decided, hey, I'm just going to slam this variable in there, cram it in there as much as possible and get what I can get. And we got 45. And that's not what you expected. This is why understanding your data types is extremely important. Imagine if this was some calculations I was doing on maybe, some physics experiment that we're doing, or some explosives that we're doing, or some chemistry that we're doing, and you got your data types mixed up. This, between 301 and 45, that's a major difference. So this is why it's extremely important to focus very closely on what data types you're using and why you're using them. Now, the majority of the times you won't ever see this, but this is just for the sake of experimentation and for you to be able to see how important it is to understand the difference between the data types. If I were to take that off there and I were to run this again, Control F5, now you can see I get the actual value there, and I get the 1 there. So I'm going to clean this up a little bit and get rid of this. So a placeholder allows me to go ahead and print things out without having to print out each line. As an example, let's say if I wanted to print these two things out. Okay. So I'm putting these two on two separate lines. Well, there's an easier way to do this. Keep in mind, this does work. Control F5. As you can see, I have 25 light bulbs. Okay. So what if I wanted to print this out on one line using one consolidated structure? The best way to do that is use what's called placeholders. And this is the way the placeholder works. First of all, I give it, I go ahead and type whatever message that I want to type. So I'm going to go ahead and do something like this. I'm going to say, in quotes, you purchased. And after that, I'm going to go ahead and put my placeholder inside of the quotes. Do something like this. And then I'm going to put, okay, the first variable is going to go here. And then I can say the second variable is going to go here. And this is almost like a zero placeholder, the first placeholder. And whenever you do something like this, this is called zero base ordering. So we have our first order and our second order. And this is where the variables are going to go. Now what I can do is put the variables that I want to go in that order. So the first variable I want was the name count. And the second one was I wanted light bulbs. So 25 light bulbs. And now I can go ahead and close that off. and then I can remove these two. So really what I'm expecting is you purchased 25 light bulbs, as we can see here. And I can even put some space in between here because we're dealing with strings here. I'm going to go ahead and hit Control F5. And as you can see here, it says you purchased 25 light bulbs. Perfect. So let's look at taking in some information into the system and actually getting information from the user and using that information and converting that information into a data type that actually works for us. So the final thing we want to look at here is this type conversion that we're going to have to do here. So right now we have this num, which is a string, this num, which is a string. We could have declared this as an integer, but for the sake of education, we're going to put this as a num because we're taking some strings in and we're going to convert them later, and we have this name here that's a string. Over here we have our instruction. As you can see, we put this inside of a variable, which is probably the best way to do this when you have a lot of instructions sometime, but we don't have a lot here, but I'm putting it inside of a variable so you can know this is probably how you'd want to do this. If this is a little bit longer, we can use that trick that we learned earlier by going in here and we can hit enter when it'll automatically put that plus there, and then we can go ahead and add whatever else we want to add inside of there, so we can actually keep the space consolidated. Over here we have our write line, and we're going to write out this here. We are reading in what the user puts. Whatever the user types, we're reading that in and we're putting it into name because we already gave them the instruction to please enter their name. Down here we have console write line. So what we are doing was saying, hello, placeholder, you are ready to go light. Are you ready to go light speed? You are ready to go light speed, I guess. Okay, so it's not a question, it's a statement, fine. And then I give it this variable here, which we retrieved from the read line. And so that's going to go inside that placeholder. Then, after that's done, we ask them another question. We say, well, we give them another command. We say, please enter a number. We put that into number 1, which is a string. And we say, give us a second number, which we put that into here. We read the number they give us. We put it into here, which is also a string. And then we write it out here. Now, what we should expect here, including here, is both those numbers combined, not really added because it's a string. So it really shouldn't add it as a number. It should only add it as a string. So if I put 1 plus 1, it should be 11, not necessarily 2. So I'm going to go ahead and hit Control F5 on this. It's asking me my name. So I'm going to put okay, enter. Are you ready to go light speed? Please enter your number, say 10, and please enter your second number. And I'm going to say 1, so that should be 101. And then go here, 10, second number was 1. After adding the numbers, we get 101. That's correct, right, because we're dealing with strings. So let's look at how we can convert these strings into integers. So like I showed you earlier, when I did something like this, and I converted a byte to an integer, I can't really do this with a string because they're not compatible types. So you can't explicitly, you can't convert it directly like this. So we need another sort of conversion. And one of the ways we can do this is what's called, I can go type int and parse, and then I can put that integer in between those brackets there. If I did the same thing here, int.parse, and put my variable inside those brackets, I won't have a problem here. Here, I'm not really adding anything up, so it really doesn't really matter. It's going to show me the numbers that I've entered. But here, because I'm doing a calculation, I have to convert those strings into integers. So now let's look and see what happens when I put 10 and 1 again. When I run this after parsing those numbers. Malik, I'll put 10 and put 1. And now we see it turns out right. The first number you entered was 10, and the second number you entered was 1. After adding the numbers, we get 11, which is exactly what we wanted to happen. Even though we're taking in strings, we can parse those strings into numbers by using the int parse. Or there's another one that we're able to use, and that's called convert to int32. So if I use the convert class to int32, this will achieve the same thing. I'm going to leave this one like this and this one like that, so you can see when I hit Control F5, it does exactly the same thing. Hopefully this video was helpful. If you have any questions, leave them in the comment section below. Make sure you subscribe, and I'll see you guys next time.